Welcome on Inside IQ. Today we are discuss one of the interesting topic of the geography that we also encounter frequently in the newspaper and current affairs, and that comes reality in our physical world. So topic is volcano. Today we are discuss some of the concept and basic behind the eruption of the volcano. So our main topic is understanding the volcanoes, origins, types, eruption and their global impact. Now we see how volcanic eruption happen. So in this picture, a basic representation is shown of the volcanic eruption. Here is a mountain, and the top of the mountain there is a gap or open channel. From this open channel, some of the molten metal comes from inside of the earth towards the earth of the surface. So these molten metal can be in the form of molten rocks, water vapor, steams, gas and many more. When these molten metal inside the earth, it known as magma, and when the magma reach on the surface of the earth, it known as lava. So magma and lava, these are the two terminology used in the volcanic process. A volcano is a vent or fissure in the earth crust through which molten rocks, materials as steam, gases, etc. erupt outward from the interior of the earth. Volcanoes are fundamental expression of the earth's internal heat and tectonic dynamics. Volcanism is a term that generally shown as the complete process or mechanism of the volcanic process that describe geological process under which the magma, gas, volcanic metal are released from the earth interior to the earth's surface. Volcanic activity is an example of endogenic process. Now, what is an endogenic process? The what are the process or activity happen under the earth or beneath the earth's surface known as endogenic process. So these are the endogenic process depending upon the explosive nature of the volcano. That means the type of the volcanic eruption nature, how much the intensity and the expansion. So different kind of landform can be created during this volcanic eruption or the process whole. So it can be intrusive or extrusive. Intrusive landform are those landform that can be created inside of the earth and can be visible only after the erosion of the earth surface. And extrusive landform can be formed. Extrusive landform are that landform that created on the land surface like mountain and ridge etc. They are chiefly driven by the movement of tectonic plates and happen at the divergent boundary, convergent zone, hot spots. In the eruption of magma appears as lava when they reach on the earth's surface, which cools and solidifies to form of the igneous rock. The main purpose of the igneous rock is the volcanic activity. Before going on the structure of volcano, how it look like, just we took a general glance on the division of the earth layer. So earth is divided on multiple layers. First topmost layer is known as crust, and crust is divided in two parts. One is continental crust and another one is oceanic crust. Next layer is comes known as upper mantle, lower mantle, upper core and inner core. So generally the whole process of mechanism of the volcanic activity comes in this division of the upper mantle and lower mantle. In between the layer of the crust and upper mantle there is a lithosphere and asthenosphere. So asthenosphere is weak layer of the topmost upper mantle side. So it is most frequent magma chamber is present in this form of the upper mantle. So the where the magma is accumulated inside of the earth known as magma chamber, and the main central pipeline through which the whole magma reach towards the earth surface is known as the main channel or main chimney, and there is a much probability that another of the main channel from the secondary cone also available, so that in the form of the composite volcano, secondary form, tertiary form also available. So in the form of molten metal, many comes output are like molten metal, rocks, water vapor, steam, gases, etc. So there is a huge S cloud, volcanic bomb. There are eruption during the explosion of the volcanic. There is created a crater or holes on the top of the most layer. There is a cone of the volcano or S layer that are directly solidify and cool down on the top of the earth surface, and the output and out layer of the magma is known as the lava on the surface of the earth. In this slide, we try to understand what are the wording and terminology used during the process of the volcanism. So we already discussed verbally in our previous slide. Let's explain in the form of the definition. First is magma. Magma is a molten natural material found beneath of the earth crust, composed of molten rocks, crystal, and dissolved gases. It forms in the astronosphere. We already seen in our previous slide where the astronosphere layer is found due to high temperature, high pressure changes, or the presence of the volatility. So basically, this is earth surface, and beneath of the earth, the molten metal known as magma, and when it reach on the surface of the earth, it known as lava. So topmost of the earth is known as lava, and under the earth is earth surface is known as magma. Second one is lava. Lava is magma that reach earth surface through an eruption. When an opening in the earth crust from which magma and volcanic gases escape or come outside of the earth's surface. Crater, a bowl-shaped pluvial at the summit of the volcano formed from the eruption or explosion. We already see in the first slide of today's discussion there is a mountain, and the top of the mountain there is a open channel or vent type crater created during the eruption or explosion of the volcanic eruption. Next, volcanic ice. It is a very fine grained metal less than a millimeter in diameter created during the explosive eruption and transported over the long distance. अगर इसके अंदर अपन एग्जांपल देखें ना, जो अभी इथोपिया के अंदर वोल्केनिक इरप्शन हुआ था, तो उसकी वोल्केनिक एस है ना टिल द रीच ऑन द इंडिया एंड बियॉन्ड द इंडिया, सो इट कैन बी ट्रेवल मोर देन द 4000 or 5000 kilometer very easily if the nature of the volcanic eruption is too high. Next is hotspot. A hotspot is fixed area in the earth's mantle from which heat rises, melting the crust above it and forming volcanoes. Now we are familiar with the basic concept of the volcanic eruption and what are the common terminology used during the eruption of the volcanic process. So in this picture, a continuous volcanic eruption is occurring and some of the molten metal come on the earth surface. These molten metal on the earth surface is known as lava. Now question is, how much distance will be covered by this lava? So it will be depend on the silica content present in the lava. So what are the main function of the silica? It will be thicker, make thicker, क्योंकि जितना ज़्यादा सिलिका प्रेजेंट होगा ना तो उसकी थिकनेस उतनी ज़्यादा होगी. उससे क्या होगा, उसका टेम्परेचर भी कूल डाउन होगा. टेम्परेचर कूल डाउन होगा तो इजीली सॉलिडिफाई हो जाएगा ऑन द सरफेस. फिर उसका जो डेंसिटी होगा ना वो ज़्यादा होगा, तो ज़्यादा डेंसिटी होने की वजह से क्या होगा, फ्लो रेजिस्टेंस क्रिएट होगा, उसकी वजह से लॉन्ग डिस्टेंस कवर नहीं कर पाएगा. और अब क्या होगा ना, जितना ज़्यादा सिलिका होगा तो वो क्या होगा, थिक की वजह से क्या होगा, जो गैसेज होगी ना वो ट्रैप हो जाएगी. तो जब जैसे एक्सप्लोजिवनेस होगा ना सडन, तो उसका एक्सप्लोजिवनेस का नेचर भी है ना, इंटेंसिटी वो भी बहुत ज़्यादा इंक्रीज हो जाती है. सो नाउ लेट्स डिस्कस. सो बेस्ड ऑन द सिलिका कंटेंट, द lava divided in two major part. One is acidic lava and second one is basic. And intermediate between the acidic and basic is known as andesite lava. Andesite lava. Now discuss. Volcanic lava is classified into two major types depending on the amount of silica present in the lava. Silica content control viscosity, temperature, flow behavior and explosiveness of the volcanic eruption. Now we took an example. We took one side water and other side honey. So water density will be much lesser and honey density is much more. So water can be easily flow through the long distance, but in the meantime the same quantity honey will be less covered distance. So acidic lava. Acidic lava is rich lava contain over more than 63% silica that is thick, highly viscous and move very slowly. Silica content 63 to 70%. Very viscous, thick, does not flow easily. Low temperature around 600 to 800 degrees centigrade. Color light color. Gas trap can be easily by the silica content more. Eruption is still highly explosiveness. If we took example for the some of the volcanic eruption that happen such kind of, so it will be Yellowstone in USA. Landform can be in the high silica content, lava dome, composite volcano, caldera, and pyroclast flow. Second one is basic lava. We can also say mafic lava. Basic lava is silica poor content. It will be around 50%. That is runny, low in viscosity, flow rapidly over long distance. So what are the characteristics of the basic lava? Silica content, it will be around 50%. Very fluid, spreads widely over long distance. High temperature due to less silica content, it will be up to 1200 degrees centigrade. Color will be dark and gas can be easily escaped due to available of the vent holes. Eruption style less explosive in nature, it will be quiet or effusive type. What are the landform can be created by the basic lava? Shelled volcano, flood basalt plateaus, lava plain. And what are the example? Deccan Traps in India, Hawaiian volcanoes, Mauna Loa Kilo in the USA. So whenever we read geography, in terms of the example and diagram, it will be necessary. So I convert acidic and basic lava characteristic in the simple form of the exam perspective. So silica content in the acidic lava high, basic lava low. Viscosity very thick, very fluid. The temperature of the acidic lava will be lower, basic lava higher. Gas content high side in the acidic lava due to high silica content, and the gas can be easily escape in the basic lava. Eruption style highly explosive, gentle and effusive type. Flow distance acidic lava will be covered short distance due to high silica content. In the same time basic lava can be covered larger distance. Landform can be lava dome, caldera, or in the form of the basic lava, sealed volcano and lava. Let's discuss what type of topography can be created by the volcanic eruption. So the landform depend upon the proportion and properties of the fragmented materials and lava. The volcanic topography can be divided into terms extrusive topography and intrusive topography. Extrusive topography means the all activity that are happen or present on the surface of the earth in the physical form. So extrusive topography, it can be created by central explosion, elevated landforms, mountain something, and depressed landform. Elevated landform as cinder cone, acidic lava, basic lava, composite cone, parasitic cone, or in the form of different landform, craters, caldera. अब क्रेटर्स कॉल्डेरा वगैरह में क्या होता है, इसमें क्या होना, मान लो कोई एक ऑलरेडी वोल्केनिक इरप्शन हो रहा है या इनिशियली में हुआ था और अभी नहीं हो रहा, तो उसमें क्या होता है ना, जब सडन मान लो कभी एक्सप्लोजिव होता है ना इरप्शन, तो उसमें क्या होता है ना कि जो ये वाला टोपोग्राफी है ना, ये भी इसको डाउनवर्ड कर देता है, इसमें बहुत ज़्यादा मतलब डाउनवर्ड कर देता है। तो उसकी वजह से क्या होगा ना, ऐसा एक एक्टिविटी मतलब ऐसा ये टोपोग्राफी क्रिएट हो जाता है कि जो ये सरफेस है ना उसके भी इनसाइड चला जाता है, तो उसको बोलते हैं अपन डिप्रेस को landform. So next is formed by fissure eruption. It will be lava plateau, lava plain, and lava dome. The main difference between the central and fissure type. Central type is this one. Like if we take example of the टूथपेस्ट, जब अपन टूथपेस्ट को एकदम से यहाँ से प्रेस करते हैं ना बॉटम से, तो इट विल बी कम आउट सडनली, सो इन द फॉर्म ऑफ सिंगल एक्सपेंशन, तो इसको अपन बोलते हैं सेंट्रल। और इसको अगर अपन ये देखें ना हॉरिजॉन्टल लाइन में कि ये एक अपना अर्थ या लैंडफॉर्म है, उसके ऊपर है ना ओवर द लॉन्ग डिस्टेंस इट विल बी क्रिएटेड इरप्शन ऑफ वोल्केनिक, तो इसको अपन बोलते हैं फिशर टाइप। एंड नेक्स्ट वन देखते हैं इंट्रूसिव टोपोग्राफी। तो इंट्रूसिव टोपोग्राफी जो भी होती है ना इनसाइड ऑफ द लैंड सरफेस होती है या बिनेट ऑफ द अर्थ सरफेस होती है, तो यहाँ पे जो भी अर्थ सरफेस के अंदर या इनसाइड बनेगी एक्टिविटी या जो भी लैंडफॉर्म क्रिएट होता है उसको अपन बोलते हैं इंट्रूसिव टोपोग्राफी। इट कैन बी बेटोलिट, लेकोलिट, फेकोलिट, लेपोलिट, सील एंड डाइक। वी विल बी डिस्कस इन अपकमिंग स्लाइड इन डिटेल। The definition of the extrusive topography is the landform created when magma erupts onto the Earth's surface as lava, ash, or volcanic fragments and cools rapidly. These features form above the ground and are shaped by the volcanic eruption. So all the extrusive topography landforms are created on the surface of the Earth. Here is a one word, cools rapidly. It will also depend on the presence of silica content. So silica content is directly proportional to cooling of lava. Cooling of lava. If silica content is more, the cooling of lava will be easily. If silica content is less, it will take longer time to cool lava. So in this picture as shown, extrusive topography are those topography that are created on the surface of the earth, like composite volcano. Composite of volcano is that one that have more than one venting for the outward of lava. Lava mesa, cinder cones, lava plateau, as cone with volcanic dome, volcanic neck with radiatic dike, caldera with cinder cone on floor and ash flow. And here is bottom side. These are the intrusive one, in which silts, stalk, batholith, laccolith, dike, dike trim, and eroded laccolith. These intrusive rock we only see after the erosion of the top of layer of the earth surface. Next one is intrusive topography. So intrusive topography landform can be created during the magma cools and solidify inside the earth crust rather than erupting on the surface. These features become visible only after the erosion of the overlying rocks or topmost layer of the earth surface. First is batholith. Batholith are large dome-shaped intrusive bodies formed when huge masses of the magma cool deep inside the earth crust. They cover vast area, often forming the core of the major mountain range inside of the earth. One of the granite. Granite is the most common rock found in the batholith. Next, laccolith. Laccolith are lens-shaped intrusive bodies created when magma intrudes between the sedimentary layer and push the overlying strata upward, forming a dome. Like this type of shape, it will be pushed from the downward and it will be upping the down. They are smaller than the batholith, usually consist of the viscous magma. Silts are horizontal or nearly horizontal intrusive. As we see in the previous slide picture, silts are like this one, horizontal one are lying in between the layer. Magma that solidify parallel to existing rock layer. They form when the magma forces its way between bedding planes without cutting across them. Next one is dike. Silts are horizontal while dikes are vertical. So in the form of vertical, these are the dikes, and in the branches of the form of the silts are in horizontal way. Dike are vertical or steep inclined magma intrusion that cut across the rock layer. They form when magma moves through the cracks or solidify, often acting the pathway for the future volcanic eruption. So जनरली जो इनसाइड ऑफ द अर्थ के अंदर जो लेयर्स होती है या रॉक्स होती है ना, तो उसी के अंदर जो वेंटिंग या रॉक फ्रैक्चर या वीकेस्ट पार्ट होता है ना, तो वहाँ से क्या होता है ना, वर्टिकल वे में मैग्मा अपवर्ड मूव करता है। तो उसी को जो वर्टिकल अपवर्ड मूव होता है ना, उसी को अपन बोलते हैं डाइक। तो आइदर it can be solidify completely or maybe some of part may be still active, so it can be pathway for the future volcanic eruption. Now we try to understand what are the primary causes behind the volcanic eruption. So some of the major causes are listed here. First is mantle convention. This theory is suggested by Arthur Holmes. According to Arthur Holmes, in the mantle there will be intensity generated due to availability of the radioactive substance. So जो radioactive substance की वजह से ना intensity generate होती है and it will be create thermal difference. So it is a circular movement of the earth mantle due to heat from the core. We already discussed in our previous slide that heat is coming from the core to mantle and mantle to core. So it will be circulate in this way. So some of the part will be go upward, rise, and in between the something is coming, it will be mantle down. So rising hot mantle melts the crust, forming magma, which move upward and erupt as volcano. Next is plate tectonics. So plate tectonics theory is suggested by Mackenzie, Parker, and Morgan in 1967. According to them, lithospheric plate will be moving due to internal forces. So it will be divided in three parts. First is convergent boundary, next is divergent, and third one is transform. So Three-part plate tectonics divided. Tectonic plate part at mid-oceanic ridge or rift zone. Mid-oceanic ridge is divergent type, allowing the ascent of the magma and resulting in the formation of the new crust. Example, East African Rift Valley. So, in this picture, there is a plate tectonics activity. Plate is moving from apart to one another in this way. One is moving this way, one another moving opposite direction. So there will be create new crust. Convergent boundary at subduction zone. One plate will be sink beneath to another, like this one. There are two plates moving each other. So one weaker plate will be downward and the stronger plate will be move upward, and there will be create a volcanic eruption or mountain, something like land forms. At subduction zone, one plate will be sink beneath to other. Melting occur with the subducted plate and the overlying mantle to create volcanic activity. Example, ring of fire, Pacific Ocean. Here is the division of the plate tectonics and resultant of their landforms. So first is divergent boundary. As we already discussed in previous slide about the divergent boundary, two plates are moving apart from each other and there will be create one thing, new landform. So it will be, we can say other terms, it is a constructive type because it created something new. Next is the convergent boundary. In convergent boundary, two plates are moving towards each other. One will be down and other will be created new. So something will be vanish here. So it will be destructive type. It will be destruct to someone. So it will be destructive type. And third one is sharing, transform plate boundary. It will be nothing to construct, nothing to divergent. It just shear to each other, and due to its shear friction, something like earthquake and tsunami, or it might be volcanic activity, but chance is very few. So these are the plate tectonics division of three parts. Next one is the volcanic plate margin at the division. So volcano at divergent plate margin, it will be volcanic ridge. Volcanoes at convergent plate boundary. Oceanic continent at convergence, it will be volcanic ridge, and in the form of the oceanic convergence, there will be volcanic archipelago. In this image, the different kind of landforms shown on the top of the Earth's surface is because of the multiple activity undergoing beneath of the Earth's surface. As we discussed, heat is coming from the core to mantle and mantle to core. It will be circulate. So during the circulation, the heat is coming from bottom to top, and it will be melt down whatever the come in between the. So it will be forming magma, and magma will be finally come out outside. So plate tectonics drive the volcanism. Divergent boundary create rifts and ocean ridge. These are rift and oceanic ridge. Volcanoes through rising magma. Convergent boundary from the trenches and subduction volcanoes, one plate sinks. Hot spot, this is a subduction, and hot spot, this is a hot spot. Hot spot volcano arise within the plate due to mantle pumps. Convection current in the mantle continuously move plate, generate volcanic activity. Next cause of the volcanic eruption is magma pressure. So let's take a example. यहाँ पे अपन देखते हैं कि अपने पास है ना गैस का सिलेंडर है. ओके, तो अब क्या होता है ना, कोई भी एक गैस का या सिलेंडर चेम्बर या कुछ भी बोलो, तो उसका क्या होता है ना, एक लिमिट होता है. किसी भी चीज़ की एक लिमिट होती है. ओके, कि उस लिमिट तक वो सस्टेन कर पाएगा. सपोज इस गैस का सिलेंडर उसका लिमिट है अप टू 10 बार, कि इट विल बी सस्टेन अप टू 10 बार. बट व्हेन वी अगेन प्रेशराइज इट अराउंड 11 बार, 12 बार, 13 बार, बट सम टाइम इट विल बी ब्रीच देयर लिमिट. तो जैसे क्या होगा ना, इसकी लिमिट ब्रीच होगी ना, तो वो क्या होगा, सडन एक्सप्लोड करेगा, सडन एक्सप्लोड करेगा. तो वही कहानी है यहाँ पे मैग्मा प्रेशर की वोल्केनो के लिए, कि जो अपना अर्थ का क्रस्ट होता है ना, उसका कोई तो एक वीक पार्ट होगा, बट अगर वहाँ तक मैग्मा पहुँचा है तो वो क्या करेगा, उसको सस्टेन करेगा अप टू एक लिमिट तक. बट वो जब लिमिट ब्रीच हो जाएगी ना, तो वो भी क्या करेगा, सडन एक्सप्लोड करेगा. सो मैग्मा प्रेशर, अकुमुलेशन ऑफ मैग्मा अकर इन चेम्बर्स बिनर द क्रस्ट, When the pressure is higher than what the rock can withstand, magma forces its way out through the surface and causing the eruption. नेक्स्ट वन इज वीकनेस एंड फ्रैक्चर इन द क्रस्ट. सो सेम यही है कि कुछ कोई तो एक पार्ट होगा अर्थ का जहाँ तक मैग्मा पहुंचा और वो उसका वीक पार्ट होगा तो वहाँ से इरप्ट होगा. सो फॉल्ट या फ्रैक्चर इन द अर्थ क्रस्ट फ्रॉम द पाथवे मैग्मा टू एस्केप वेयर द मेजोरिटी ऑफ लोकलाइज वोल्केनिक इवेंट अकर्स. नेक्स्ट वन थर्मल एनोमलीज. हाई टेम्परेचर रीजन. सेम अपन ने देखा था कि जो हार्म्स ने मेंटल कन्वेंशन वाला थ्योरी में सजेस्ट किया था कि ड्यू टू रेडियो एक्टिविटी की वजह से क्या होती है ना, थर्मल डिफरेंस क्रिएट होता है. तो वही है हाई टेम्परेचर रीजन इन द मेंटल ऑफन ड्यू टू द डिके ऑफ द रेडियो एक्टिव एलिमेंट कंट्रीब्यूट टू मैग्मा फॉर्मेशन एंड वोल्केनिज्म. नेक्स्ट वन इज ओरिजिन ऑफ गैसेज. ग्राउंड वाटर रीच द इनर पार्ट. अब क्या होगा ना कि मान लो कहीं पे मैग्मा अकुमुलेट होकर रखा हुआ है बिनेट ऑफ द सरफेस और सडनली वहाँ पे क्या होगा ना ग्राउंड वाटर या कोई भी वाटर चैनल पहुँच गया वहाँ पे, तो वहाँ पे क्या होगा ना वो ऑलरेडी स्टीम में कन्वर्ट होना चालू हो जाएगा. तो उसकी वजह से भी क्या होता है ना गैसेज वगैरह फॉर्म होना स्टार्ट हो जाएगा. ग्राउंड वाटर रीच द इनर पार्ट ऑफ द अर्थ थ्रू क्रैक्स गेट कन्वर्टेड इनटू वेपर विच एक्ट एज द प्रोपेलिंग फोर्स इन द इरप्शन. तो अब क्या होगा ना स्टीम होगा तो स्टीम का नेचर क्या है ना, इट विल बी गो from bottom to top, so it will be going onward the top and it will be create pressure on the top of the part. next isothermal adjustment. अब isothermal adjustment का सिंपली देखो क्या है, अगर मैं एक कॉमन वे में बोलूँ ना कि ये अपना अर्थ है, ओके सरफेस, दिस इज द सरफेस ऑफ द अर्थ. तो अब इसमें अभी क्या है ना हिमालय, अभी सपोज हिमालय की हाइट है ना 8000 मीटर है, 8000 एंड प्लस. तो अब क्या है ना जितना 8000 एम प्लस ये अबो द ग्राउंड है ना, तो आइडियली इट विल बी मोर देन 8000 इन द बिलो ऑफ द अर्थ. सो बिकॉज ऑफ द दिस इट विल बी बैलेंस एंड सस्टेन ऑन द अर्थ सरफेस. तो ये भी एक है ना बैलेंस है. अगर इसका बैलेंस कहीं से भी है ना डिसबैलेंस होगा या डिस्क्रिपेंसी क्रिएट होगी ना, इट विल बी फॉल डाउन और समथिंग विल बी हैपन. So isothermal adjustment shift casual pressure balance, creating the fractures, enabling the magma ascent, which increase the likelihood of the volcanic eruption. Volcano can be classified on the following basis. First is frequency of the eruption. So according to eruption, it can be active volcano, dormant volcano, or extinct volcano. Pattern of the eruption: centrally explosive or fissure type. Central example Hawaiian volcano, Stromboli, Volcanian, Vesuvius, and Pelian. Based on the topography, it can be shield volcano, composite volcano, caldera, basaltic flow, filled volcanoes, mid-oceanic ridge volcanism. And based on the location, it will be tectonic boundary and it will be hotspot volcanism. Based on the frequency of the eruption, it classifies further in three parts: active volcano, dormant, and extinct type. So, active volcano, a volcano that has erupted in the recent past, is currently erupting or showing sign of the possible future eruption. One of the cause like earthquake, gas emission, or ground deformation. Continuous or periodic eruption or strong geothermal and seismic activity, etc. For example, Barren Island. Barren Island is India's standalone active volcano. This one is shown in the picture below. Mount Stromboli, Italy, Hayaligubbi, Ethiopia, and Mauna Loa Island of Hawaii, USA. So Hayaligubbi, Ethiopia, just recently erupted. This shown in this picture, and this is a huge explosive in the nature from as coming from the Ethiopia to India and more beyond the India. So it will be highly silicated type acidic nature. Dormant volcano, it is a volcano that has not erupted for long time but still has potential to erupt again in the future because of its magma supply is not completely extinct. Dormant can be classified in the range of the 100 to 1000 year of inactivity of the volcano. Example, Mount Fuji, Japan, dormant. It will be erupted approximately in the 1750 century. Extinct volcano, volcano that has not erupted for tens to thousands of years and is not expected to erupt again because it has no magma supply. So magma supply can be closed out completely, so it will be classified extinct type. Kola, Hawaii volcano in the USA. Next one is based on the pattern of eruption. So first is central eruption volcano. As shown in the picture, there magma is coming from bottom of the earth to surface of the earth. It will become from the central pipeline, so it will be coming from centrally vertically. So a central eruption volcano is volcano where magma rise and erupts through a single central vent or crater, forming a conical structure over repeated eruption. Because of the magma vent, lava, ash, crater, second vent और layer of the, तो यहाँ पे क्या होगा ना, जैसे ही लावा निकलेगा ना, इट विल बी सॉलिडिफाई एंड कूलिंग डाउन. तो ये जब भी सॉलिडिफाई और कूलिंग डाउन हो जाएगा ना, तो इट विल बी क्रिएटेड ए लेयर एंड इट विल बी व्हेन अगेन इरप्टेड द लावा विल बी कमिंग एंड it will be rise like a concept. So what are the characteristic of the central eruption volcano? Magma reach the surface through one main central crater. Cone shape structure, repeated eruption build a conical shape around the vent. Lava and pyroclast eruption produce lava flow, ash, cinder cones, gas, water, steams, vapors. Explosive or effusive type can be either quite violent and depending on the magma viscosity based on the silica content. Formation develops from the repeated eruption over the time at one central point. Size usually smaller than fissure volcano but can be formed composite stratovolcano or cinder cone. Stratovolcano are that volcano that have multiple vent to out magma on the earth surface. What are the advantages of this kind? Produce fertile soil from ash and lava weathering over the longer period of time. Can form geothermal energy source, create tourism and seismic landscape. In the central eruption, next one is Hawaiian type volcano. So it is just shown on the picture. Hawaiian eruption are broad, gentle, sloping. These are broad and sloping is gentle, not like a cone. So broad, gently sloping silt volcano formed by the low viscosity basaltic lava from hot spot. Erupting quietly, effusively repeated lava flow built wide island. Example Mount Lava, Kilo, Hawaii in USA. Stromboli type volcano, ए मॉडरेटली एक्सप्लोजिव वोल्केनो. अब एक्सप्लोजिव होगा तो क्या होगा ना, ये देखो यहाँ पे क्रेटर बन रहा है ना, तो क्या होगा ना, जैसे एक्सप्लोजिव होगा ना, जो भी सराउंडेड बाई जो भी लैंडस्केप होगा ना, तो उसको वो ब्लास्ट कर देगा. सो इट मॉडरेटली एक्सप्लोजिव वोल्केनो डेट इजेक्ट लावा बॉम्ब. It will be lava bomb, cinders and ash from the central vent. Eruptions are intermittent and mild, producing steep sides cone. It will be steep, neither cone nor gentle slope. So with lava accumulated around the vent due to less fluid and more viscous. Example for Stromboli, Italy. In central type, next is volcanic type eruption. So in this image shown, the volcanic type of eruption, the eruption is looking like too explosive, as is going too much high. So volcanic type volcano are short, violent, explosive eruption that eject dense ash cloud, volcanic bomb, and block due to viscous gas-rich magma, blocking the event named after volcanic island, Italy. So it will be named after the volcanic island in Italy. Highly explosive, louder and stronger than Stromboli eruption, produce thick, dark ash clouds rising several kilometers. Magma is highly viscous and sticky. So it will be highly viscous and sticky वजह से होने से क्या होता है ना, it will be not travel too much and gas will be trapped inside there. So viscous, next is viscous type volcano. It will be highly danger volcano. I mean say. Our viscous type volcano are extremely explosive. Is wording extremely explosive, highly violent volcanic eruption that eject huge ash column, pumice and pyroclastic flow into the atmosphere. They are named after the Mount Vesuvius, Italy. So volcanic type also it is a mountain volcano island, and Vesuvius type is also it named after the Mount Vesuvius in Italy. It is destroy Pompeii. Pompeii is a city. Pompeii. Pompeii is a city in Italy. In 79 AD, there were a volcanic eruption occurred. It spread smoke and toxic gas in 20 miles into air. You can suppose of what is the meaning. Which soon spread to town and they also called the pillion type of volcano. I see image during the reading. The Pami city completely vanished down due to this volcanic eruption. So what is the meaning of the volcanic eruption? It will be highly explosive type also, because of the too much toxic gases are ejected. Next type is fissure eruption volcano. So as shown in the picture, we already see in the central type. Central type is like a cone or something like this one, and central pipe is coming from the bottom to top, and the magma reach from bottom to top the surface of in the central pipeline. But in the fissure type, there will be a land, and the magma will be carrying forward in the way of horizontal way. So the main difference between the central and fissure is this one. It is a type of volcanic activity where magma erupts through the long cracks, fissures in the earth crust, instead a single central vent. The lava flow out quietly and is spread over the large area. What are the characteristics? Lava emerges from the elongated crack, often several kilometers long. No central cone or craters. Produce vast lava plateaus or basalt plain. Eruption is effusive, not explosive type. Lava type basaltic, very low viscosity. What are the examples? Deccan Traps in India, one of the largest fissure eruption in the Earth history. Columbia River basalt and Icelandic fissure eruption. Next division is based on the topography. So first volcano is sill type volcano. In the sill type volcano, the characteristic is large type of base. Bottom base is large, continuous flow of the magma. Eruption style is not too explosive, and lava content is basic type. Basic means less silica. Less silica means it travel over longer distance. Sorry. So silt volcano, these are the broad, gently sloping volcanic landforms built almost entirely by low viscosity basaltic lava that flow easily and spread over great distance. What are the characteristics? Shape broad from the bottom, dome-like with very gentle sloping around 5 to 10 degree. Lava type basaltic, low silica, low viscosity. Eruption style effusive, not explosive. Size, it is one of the among largest volcano on the earth. This is the keyword. Among largest volcano on the earth. Structure built by thousands of the thin layer of lava. Because of lava is continuously solidify. Hazard, mainly lava flow, rarely explosive. Example, Mauna Lava in the Hawaii, USA. Next one is composite volcano. As shown in the picture, there is a multiple vent for the outward of the magma. So composite volcano, also called stratotype volcano, are steep conical volcano formed by altering layer of lava, flow, ash and pyroclastic material. They are typically explosive type. Sealed volcano are not explosive, but composite or stratotype volcano are explosive due to viscous magma with high silica content. High silica, same, less flow, high density. So what are the characteristics? Steep side, symmetrical cone. Lava type, high silica, viscous, high density. Eruption style, explosive, producing as pyroclastic, volcanic bomb. Size, medium to large, up to several thousand of meter high. Structure, central vent with summit crater. Hazard, extremely dangerous. Stratotype or composite type volcano are extremely dangerous. Example, Mount Fuji. Mount Fuji is, I think, dormant volcano type. Mount Vesuvius and Mount Vesuvius in Italy and Mount Fuji in Japan. Next one is caldera. Caldera, it is a largest basin shape depression form. This is depression type of landform. When a volcano collapses after the massive eruption emit in the magma chamber, it is the larger than the normal crater and can be span several kilometers. Characteristic, large circular oval depression. As shown in this picture, this is the Yellowstone caldera, USA. Lava type, high silica, viscous, extremely explosive, much larger than summit crater, extremely dangerous. Now let's discuss what are the effects of volcanic eruption. So first is environmental effect. Atmospheric impact. Volcanic ash and gases like sulfur dioxide rise into atmosphere, forming aerosols that block sunlight. Aerosols are the particles like this way that block the sunlight. This means it will be cooling down temperature. Cooling down temperature. This can cause global cooling. For example, Mount Pinatubo in 1991 lowered global temperature by around 0.5 degrees centigrade. Air pollution, release of multiple gases like carbon dioxide, sulfur dioxide, hydrogen dioxide, and ash can be cause breathing difficulties, acid rain, and reduced visibility. Landscape modification, lava flows, ash deposition, and pyroculous metal reshape landform, creating plateaus, caldera, cones, and new island. Something. Next one is economic effect. What are the economic effect happen due to volcanic eruption? Destruction of infrastructure. Lava flow and ash can be destroy roads, bridges, airport, building, power lines, and even like Pompeii city in the Italy completely vanish out. Agriculture damage. Ash fall smoother crops, contaminate water, and kills livestock. Soil fertility can be increased, but it will be take longer time. So soil fertility increase in the long term due to mineral rich deposit. Tourism and economy. Eruption disrupt tourism but can be increased tourist interest later. For example, island, but it takes several and multi many years. Next effect on social and human effect: loss of life and injury. Pyroclastic flow, layers, and ashfall are deadly. Historical example: Pompeii city in Italy and Nevado di Rouge in 1985. Displacement of people, evacuation and long-term relocation due to unsafe condition. Health hazard, respiratory issue, eye irritation, skin problem from ash and gases. Geological effect, formation of the new landform. Stratovolcano, shield volcano, caldera, lava plateaus, triggering secondary hazard like earthquake, landslide, tsunami, underwater eruption, etc. Next positive effect is fertile soil. Volcanic soil and soils are extremely fertile for the agriculture purpose. Geothermal energy. Eruption indicate geothermal energy potential like Iceland, New Zealand. Mineral deposits. Volcanic process bring mineral like copper, gold, diamond, basalt, etc. to the surface. Conclusion: if we say volcanic eruptions are powerful natural processes that remind us of the Earth's dynamic interior. Though destructive, they also renew landscape, enrich soil, and provide vital resources. Understanding volcanic behavior is essential for reducing risk and harnessing their long-term geological and economic benefit. One of the famous quote related to volcanoes and that can also apply in our daily basis life. So people never believe in volcanoes until the lava actually overtakes them. So many things is happen behind the bar, but it will be reflected when it come out. So thank you very much, Jain Javar. If you have any query, please comment or you can be use the Gmail address given below. So thank you. Bye. Have a good day.